Oh, hey guys, today let's solve Leetcode 217, which is contains duplicate. It's a really easy problem and it's uh, frequently asked during online assessments of a few companies. So, so the problem says that given an integer array nums, return true if any value appears at least twice in the array, and we have to return false if every element is distinct. So let's take an example and understand this better. Let me just take the example which is given in the question itself. So if I take 1, 2, 3, 1, so you can see that uh, we have 1 repeating twice. So at index 0 and at index 3. So in this case, the answer would be true because we do have duplicates, but we don't need to state which element is a duplicate. We just need to state if there are any duplicates. So, I mean, the brute force way, which uh, probably everyone would understand, is going over all the elements, I mean, and comparing them to each other. So, just choose yellow here. So, brute force. Okay, just change the color. Yeah, so what we do in the brute force is, I mean, if we have, okay, so if you have 1, 2, 3, 1 as the array, so we can have, um, you know, one element I here and another pointer j here. So, or, we can just keep it in the next position because there's no point comparing it to itself. And what we basically do is check if 1 is equal to 2, and after that we just move j forward since 1 is not equal to 2, and then we check if 1 is equal to 3. Since it's not equal to 3, we move j forward again, and now see that 1 is equal to 1. So at this point I is uh, I mean the uh, number at I is equal to the number at j, so we know that there's a duplicate, and we can return true. But it's not always the case that the first number or the number at index 0 would be the duplicate, and we would also have to check the other numbers. So if we want to check 2, so one index, say I would be here, and then we can keep j starting from here. So we'll have to check 2 with 1, then we have to check 2 with 3, and then uh, 2 with 1 again. So as you can see, we will have to use two loops here. So the first loop, the outer loop, would be to iterate over all the elements one by one, and the second loop actually would be to compare each element with all the other elements. So something like for I to n here, and then you'll have another for j to n here. Then here you do if say num of I equal to num of j. So like this. So as you can see, this would be of n or n square solution since we have two loops. So can we do anything better? So yes, we can absolutely do something better, and the next way is using sorting. So if you observe, if we have, again, if I take nums as equal to 1, 2, 3, 1 here, and let's say I sort it and I get 1, 1, 2, 3. So here you can see that, so okay, so here you can see that the duplicates basically appear together. So if the duplicate, like the number here is at 0th position, its duplicate would appear the first position. So if there is no duplicate, then the ith element would not be equal to the I plus 1th element, which is in this case between 2 and 3. So basically what we can do is, we can just sort it and then check if, we can do a single iteration. So for I is equal to 0 to n, then you can check if I or nums of I is equal to nums of I plus 1 and return true like this. So, and yeah, obviously before we run the for loop, we should actually sort nums and then run this. So in this case, the time complexity would be O of n log n. So essentially what we are doing is, log n is sorting. If you use, I mean, binary search, then it's sorting. And after we sort, obviously we need to go over, each of the elements. So here there are 4 elements. So we need to go over each of the elements and check whether nums of I is equal to nums of I plus 1. So that makes it O of n time complexity. So here space complexity is O of 1. And even in this case, space complexity is O of 1. Now the question arises, so what's the most optimal approach? So there's one more approach where we can reduce the time complexity to O of n, but the space complexity would also be O of n. So let's use a hash set. So in which is the most optimal approach, even though we're trading off time and space here. So yeah, I mean, you would have guessed, or at least have got an idea of this approach. So what we do is, again, we take up 1 2 3 1. Essentially we would have a set here, and we can iterate over each element. So let's say we are here if we are at 1, uh, we can check if 1 exists in the set or not. So if we have a set like this, so at the first iteration we can check if 1 is in the set. So it's not in the set. So uh, it has not appeared again before. So if we go to 2 now, okay, before we go to 2, we'll have to add 1 to the set. So the set basically contains all elements that have already appeared. So let us add uh, 1 to the set. Now in the second iteration, if you have 1 2 3 1, and the set contains only 1. So now if you are at 2, again we check if 2 is in the set. No, 2 is not in the set, so it has not appeared before. And now we add 2 to the set. So next here 1 comma 2, and similarly let's go to 3 now. So if you have 1 2 3 1, if we go to 3, we check, it's 1 2, if 3 is in the set or not. So the element 3 is not in the set, so we add it to the set. Simple. And fourth, so this is where it gets a bit interesting. 1 2 3 1, so we have 1. So now the case is, we have used it. Yeah, so now you can see that 1 appears in the set. So essentially, uh, yeah, so since 1 is in the set, it has indeed appeared before, at the 0th position. So it's a duplicate. And once we find that some element is in the set, then we return true because it's a duplicate, and we don't need to continue further. So if there were like, I don't know, like 100 elements further, we don't need to check the other 96 elements because you already know that there's a duplicate. So The advantage of this is that, checking if an element in the set is in the set or not is a O of 1 operation in almost all the languages. So if in the worst case, if we have to check, suppose all the 100 elements, so the worst case time complexity would be O of n. So O of n worst. And space complexity, since, again, like if we have all the 100 elements in the set, uh, or if we have like 99 elements in the set and the 100th element, uh, if we have 99 unique elements in the set and the 100th is a repetition of the first element or any of the other elements, then we would have approximately n elements in the set. So the space complexity would be O of n worst. So as you can see, we have traded a bit of uh, 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 space complexity or space, to improve our time complexity too often. So that's all for this video, and I'll see you in the next one. Okay, before that, I'm sorry, before that, let's go over the code as well. So yeah, so coming to the code, it's quite simple. So we have asset, which is, at first it's empty, and then we go over all the elements one by one in nums, and if num n is in the hash set, then we return true. Otherwise we add the element n into the hash set. So if we loop through all of the elements in nums and we don't find any duplicate, then we return false, because there is no duplicate, all the elements are unique. And yeah, if let's see, I have submitted it already. So as you can see here, it's kind of better than 92%, which is quite good. So yeah, thank you again. And yeah, this is my first YouTube video after a long time, so I just messed up a bit.